Hi everyone. Today we're going to look at solving equations involving perfect squares. And we can use a couple different methods of this, either undoing or looking inside. So let's get going with some examples. First off, when I say equations with perfect squares, what I mean is I have a parentheses squared. And my whole goal is to get rid of that parentheses squared to just end up with a linear equation on the right or left, but in this case, left-hand side. So if I look at part A, 3x minus 4 squared equals 25. Well, I know that there's two numbers squared that can equal 25. Those two numbers are either 5 or negative 5. So I can write a new equation saying that whatever was in my parentheses, 3x minus 4, equals positive or negative 5. Now, since that right-hand side has two different possibilities, I'm going to take my equation and split it into two separate equations. And those two equations will be 3x minus 4 equals 5, or 3x minus 4 equals negative 5. And from here, I'm simply solving a two-step linear equation. Add 4 to both the left and the right to eliminate the minus 4. So we have 3x equals 9, or 3x equals negative 1. Now in both instances, I have 3 times x, and to undo times 3, we divide by 3 to both sides. And I end up with my solutions x equals 3, or x equals negative 1/3. And those will be my two answers to example A. Now, as we keep going through this, you're going to notice that sometimes it's not as easy to figure out what number squared will give me a good answer. Such as the instance in example B, where we have 3x minus 4 squared equals 12. In that case, I need to come up with a way to undo to the power of 2, just like we came up with ways to undo subtract 4. To undo to the power of 2, I need to square root the left-hand side of my function. But anything I do to the left-hand side of a function also needs to be done to the right-hand side. So 3x minus 4 equals the square root of 12, but we know that there's actually two possible answers to this. So we write the positive and negative square root of 12. So now in order to solve, I'm going to use the same process as I did earlier. Add 4 to both the left side and the right side. So we get that 3x equals 4 plus or minus the square root of 12. Then I need to undo my 3 times x, so I'm going to divide both sides by 3. Remember to write my 2 for 12, divide by 3. And we have that x equals 4 plus or minus the square root of 12 divided by 3. Now, in a few more lessons, we'll learn that we could rewrite that as 4 plus or minus 2 times the square root of 3 all divided by 3, because we'll learn how to do something called the simplest radical form and simplify the square root of 12 down to 2 times the square root of 3. For now, you don't have to worry about that. In a couple weeks, we'll get there. Part C. Part C will give us an even nicer answer. 3x minus 4 squared equals 0. Now I'm a little bit concerned by that because it equals 0 and not a number. But we can use the same ideas that we've been doing. Oh, I need to get rid of something squared. So I'm going to take the square root of both the left and the right-hand side of my equation. When I do that, my squared and my square root undo each other. So 3x minus 4 equals the positive or negative square root of 0. But I want to think for a minute. The square root of 0 is 0, so that's really positive or negative 0. There's no negative 0 or positive 0. 0 is just neutral. So my only answer is 0 for the right-hand side. So 3x minus 4 equals 0. Now to solve, undo subtract 4 by adding 4 to the left and the right to get 3x equals 4. Then divide both sides by 3 to undo the 3 times x to get to your final answer of x equals 4/3.